Welcome to Module 5 of the Simple Understanding CPIM 9.0 full course. The name of this module is External Supply and Key Support Functions. In Module 4, we studied internal supply. We learned how organizations create master schedules, calculate material requirements, validate capacity, promise customer orders, and respond to internal supply changes. However, most organizations cannot produce everything they need internally. They depend on external suppliers for raw materials, components, packaging, equipment, technology, transportation, maintenance services, professional services, and many other resources. The performance of these suppliers directly affects the organization's cost, quality, inventory, lead time, flexibility, sustainability, risk, and customer service. A company may have an excellent production plan. However, that plan will fail if an important supplier delivers the wrong material, provides poor quality, misses the required date, or becomes unavailable. External supply management is therefore much more than searching for the lowest price. The organization must select suitable suppliers, establish appropriate relationships, communicate requirements, create contracts, monitor performance, manage risks, support sustainability, coordinate transportation, and prepare for possible disruptions. The organization must also maintain its equipment and facilities. A production plan cannot be completed when important equipment is unavailable because maintenance was ignored. Maintenance decisions affect capacity, quality, safety, inventory, cost, and customer delivery. Modern organizations must also consider what happens to products and materials after their original use. Returned products, damaged goods, reusable components, recyclable materials, recalled products, and end-of-life assets must move through carefully designed reverse logistics processes. This module therefore connects procurement, purchasing, maintenance, risk, sustainability, waste reduction, and reverse logistics. A company must answer several important questions. Which supplier should we select? Should we use one supplier or several suppliers? Should we use sourcing locally or internationally? What type of relationship should we develop with each supplier? How should supplier performance be measured? Which purchasing method should we use? How should materials and services be released? What is the true total cost of a purchasing decision? How should equipment maintenance be planned? What risks exist within the external supply network? How can the company prepare for supplier disruptions? How should sustainability be included in sourcing decisions? And what should happen to products after they are returned or reach the end of their useful lives? Module 5 helps us answer these questions. Don't forget, all videos on the Simple Understanding YouTube channel are translated. You can also listen to dubbed audio in your main language. Before we begin Module 5, remember that the Simple Understanding CPIM 9.0 study materials are available to support your preparation and help you maximize your chance of passing the exam on your first attempt. Bundle 1 is the full learning bundle. It covers all 9 CPIM 9.0 modules and 38 sections. It includes clear explanations, real-world company case studies, and a comprehensive mathematics section with step-by-step formulas and solved examples. Bundle 2 is the MCQs practice bundle. It contains more than 6,200 multiple-choice questions, including conceptual, theoretical, scenario-based, and quantitative questions. Every question includes a detailed answer explanation to help you understand the concept and learn from your mistakes. Bundle 3 is the flashcard bundle. It contains 1,800 flashcards covering important terms, definitions, formulas, and key CPIM concepts. The flashcards are ideal for quick daily revision and final exam preparation. The download link for all 3 bundles is available in the video description. Use the Learning Bundle to understand the concepts, the MCQs bundle to test your knowledge, and the flashcard bundle to strengthen your memory. Now, let us explore the 5 sections included in Module 5. Module 5 consists of 5 sections. Section A, Suppliers and Procurement. This section explains how organizations identify, evaluate, select, and manage suppliers. We will examine sourcing alternatives, supplier relationships, supplier certifications, supplier scorecards, contracts, communication, collaboration, and procurement planning. Section B, Purchasing and Maintenance. This section explains how organizations purchase materials and services and release requirements to suppliers. We will examine purchase orders, contracts, blanket orders, consignment, vendor-managed inventory, supplier scheduling, electronic data interchange, inbound logistics, total cost of ownership, and maintenance strategies. Section C, Risk Management. This section explains how organizations identify, evaluate, prioritize, and respond to external supply risks. We will examine risk categories, risk mapping, sourcing dependencies, supplier disruptions, strategic buffers, redundancy, analytics, scenario planning, and supplier business continuity. Section D, Sustainability Strategies. This section explains how environmental, social, ethical, and economic considerations influence external supply decisions. We will examine responsible sourcing, supplier codes of conduct, environmental and social performance, carbon emissions, life cycle assessment, resource use, supplier development, and sustainability metrics. Section E, Waste Hierarchy and Reverse Logistics. This section explains how organizations manage materials and products after use, return, damage, recall, or end of life. We will examine prevention, reduction, reuse, repair, refurbishment, remanufacturing, recycling, recovery, disposal, circular economy principles, product returns, recalls, and product disposition. Let us begin with Section A. Suppliers and Procurement. Section A. Suppliers provide the materials, services, equipment, information, and capabilities that an organization needs to operate. Supplier decisions can affect the entire product lifecycle. A supplier may influence product design, cost, quality, technology, lead time, inventory, sustainability, resilience, and customer satisfaction. Organizations should therefore use a structured process for selecting suppliers and managing supplier relationships. In this section, we will study 5 key topics. Topic 1. Supplier selection and sourcing alternatives. Supplier selection begins with understanding the organization's requirements. The organization should define the material or service required, technical specifications, quality requirements, required quantity, delivery timing, capacity needs, expected lead time, service requirements, regulatory requirements, sustainability requirements, information security requirements, acceptable cost. The organization can then identify possible suppliers and evaluate their capabilities. Supplier selection criteria may include price, total cost, quality, capacity, delivery performance, lead time, technology, financial stability, location, flexibility, management capability, risk, sustainability, certifications, past performance. The organization must also choose an appropriate sourcing strategy. Sole source. A sole source exists when only one supplier is capable of providing the required product or service. This may result from patents, specialized technology, regulation, or unique capability. The organization has limited alternatives and may face high dependency. Single source. Single sourcing occurs when several suppliers could provide the item, but the organization intentionally selects one. This may create stronger relationships, better pricing, and easier coordination. However, disruption at the selected supplier can stop supply. Multiple sourcing. Multiple sourcing uses more than one supplier for the same requirement. This can increase competition and reduce dependency. However, volumes are divided, relationships may be weaker, and quality or specifications may vary. The organization must also consider supplier location. Onshoring. Onshoring means sourcing within the organization's home country. It may provide shorter lead times, easier communication, and lower transportation risk. Costs may be higher. Nearshoring. Nearshoring means sourcing from a nearby country or region. It may balance cost with shorter transportation distances and easier coordination. Offshoring. Offshoring means sourcing from a more distant country. It may provide lower production cost or specialized capability. However, it can create longer lead times, transportation risk, currency exposure, and regulatory complexity. Reshoring. Reshoring means bringing an activity back to the home country after it was previously performed elsewhere. Friendshoring. Friendshoring means sourcing from countries considered politically or economically aligned. No sourcing alternative is automatically best. The decision should reflect cost, availability, lead time, customer requirements, risk, technology, and strategy. Real-world company example. Apple. Apple manages a global supply chain involving thousands of supplier facilities across many countries. Its suppliers support different product lifecycle activities, including materials, components, assembly, logistics, and recycling. Apple must evaluate more than purchase price. It also establishes requirements related to quality, labor, human rights, health and safety, ethics, and environmental performance. This illustrates why supplier selection is a multidimensional decision. CPIM key takeaway. Supplier selection should consider total value and risk. The lowest price supplier is not necessarily the supplier that creates the lowest total cost or the strongest long-term performance. Topic 2. Supplier relationships and relationship types. Organizations do not manage every supplier the same way. The appropriate relationship depends on strategic importance, supply risk, purchase value, technology, product complexity, market availability, required collaboration. Several supplier relationship types may be used. Transactional relationship. A transactional relationship focuses mainly on individual purchases. Products are usually standardized, several suppliers are available, and switching costs are low. Price and basic delivery performance may receive the greatest attention. Partnership. A partnership involves greater communication, trust, information sharing, and joint improvement. The organizations may work together on quality, cost, delivery, inventory, and process improvement. Strategic alliance. A strategic alliance is a deeper relationship formed to achieve important long-term goals. The organizations may share technology, investment, market knowledge, or product development activities. Joint venture. A joint venture creates a separate business owned by two or more organizations. The partners share resources, risk, control, and benefits. Contract manufacturing. A contract manufacturer produces goods for another organization. The brand owner may control product design and market strategy, while the contract manufacturer provides production capability. Subcontracting. Subcontracting transfers a specific part of work to an external provider. The original organization normally remains responsible for the customer commitment. A strong relationship can create benefits such as better quality, shorter lead times, improved technology, lower inventory, better visibility, faster new product introduction, reduced waste, improved customer service, access to new markets. However, trust does not remove control. Responsibilities, performance requirements, data ownership, risk, and commercial obligations should remain clear. The company should segment suppliers. Strategic suppliers may require executive reviews, joint projects, and long-term plans. Routine suppliers may require simpler management. Treating every supplier as strategic wastes resources. Treating a critical supplier as a simple transactional vendor creates risk. Real-world company example. Toyota. Toyota describes supplier relationships based on mutual trust, collaboration, communication, and mutual growth. Its supplier associations support competitiveness and improvement across its network. The relationship is not limited to negotiating a purchase price. Toyota and its suppliers may work together on quality, technology, production preparation, cost, and continuous improvement. CPIM Key Takeaway. The relationship model should match the supplier's strategic importance, risk, capability, and required level of collaboration. Topic 3. Supplier evaluation, certification, and scorecards. Supplier evaluation should continue after the supplier has been selected. Organizations need evidence that suppliers are meeting expectations. Supplier performance measures may include quality, delivery, cost, responsiveness, lead time, capacity, innovation, risk, sustainability, customer service. A supplier scorecard combines selected measures into a structured performance view. Suppose a company uses the following weighted scorecard: quality 35%, delivery 30%, cost 20%, sustainability 10%, innovation 5%. The supplier receives the following scores out of 100: quality 90, delivery 80, cost 85, sustainability 70, innovation 60. The weighted score is calculated as follows: quality 90 multiplied by 0.35 equals 31.5. Delivery 80 multiplied by 0.3 equals 24. Cost 85 multiplied by 0.2 equals 17. Sustainability 70 multiplied by 0.1 equals 7. Innovation 60 multiplied by 0.05 equals 3. Total weighted score equals 31.5 plus 24 plus 17 plus 7 plus 3 equals 82.5 out of 100. A scorecard should not hide serious failures. A supplier should not receive an acceptable total score when it has a critical safety or quality problem. Some requirements should be mandatory rather than averaged. Supplier certification may confirm that a supplier has demonstrated certain capabilities or systems. Certification may relate to quality management, environmental management, information security, food safety, industry regulations, labor standards, process capability. A certified supplier may require less incoming inspection when its processes are stable and trusted. However, certification should not replace performance monitoring. An organization should also verify that certifications are current and relevant. Real-world company example: IKEA. IKEA uses its I-Way supplier requirements to establish environmental, social, working condition, and other expectations for suppliers and service providers. Its framework includes minimum requirements and higher levels of performance. IKEA also uses audits and improvement activities to identify gaps and support supplier development. CPIM Key Takeaway. Supplier scorecards should combine relevant performance measures, while mandatory safety, ethical, regulatory, and quality requirements should never be hidden by averages. Topic 4. Procurement Planning, NPI, and Engineering Collaboration. Procurement planning determines how external supply will support future business requirements. The procurement plan should consider demand plans, production plans, new product introductions, engineering changes, product discontinuations, capacity requirements, supplier lead times, market conditions, risk, budget. Procurement should participate early in new product introduction. If procurement becomes involved only after a product has been designed, the organization may discover that a material is unavailable. Only one supplier can produce a component. Lead time is too long. The design is expensive to manufacture. The supplier lacks capacity. The product does not meet regulatory requirements. The component will soon become obsolete. Early supplier involvement can improve design decisions. Suppliers may provide information about materials, manufacturing methods, tolerances, technology, cost, capacity, tooling, lead time, sustainability. Procurement must also communicate engineering changes. A change may affect specifications, drawings, bills of material, testing, quality plans, tooling, supplier inventory, minimum order quantities, existing purchase orders. The organization should establish an effective date plan. It should determine when the new version begins, what happens to the old version, which supplier orders must change, whether old materials can be used, returned, reworked, or scrapped. Poor communication can cause a supplier to continue producing an obsolete component. Procurement must also communicate end-of-life requirements. Suppliers may require a final lifetime buy, particularly when a component is being discontinued. Real-world company example: Apple. Apple suppliers support many stages of product development and production. A product change may affect materials, components, manufacturing processes, testing, tolling, and supplier capacity. Supplier standards and collaboration must therefore be connected with product design, engineering, quality, production, and logistics, rather than being handled only after a final design is completed. CPIM key takeaway: procurement should participate early in product development and engineering changes. Early supplier involvement can reduce cost, lead time, quality risk, obsolescence, and launch problems. Topic 5. Contracts, communication, and supplier collaboration. A contract defines the obligations of the buyer and supplier. Contract terms may address price, quantity, product specifications, quality, delivery timing, transportation, ownership, payment terms, warranty, confidentiality, intellectual property, information security, inventory, liability, termination, dispute resolution, regulatory compliance, sustainability. The contract should clarify who is responsible for inventory. For example, inventory may be physically stored at the buyer's facility but remain owned by the supplier until it is consumed. The agreement should define when ownership and financial liability transfer. Contracts should also address changes. A supplier may require compensation when a buyer cancels orders after the supplier has purchased materials or reserved capacity. Effective communication is essential. The buyer and supplier should agree on communication frequency, information format, responsible contacts, escalation procedures, forecast sharing, order changes, technical changes, quality problems, risk alerts. Information technology can support collaboration through supplier portals, electronic data interchange, cloud platforms, shared forecasts, digital quality systems, inventory visibility. However, technology cannot correct poor relationships or unclear responsibilities. Cultural differences may also influence communication. Organizations may differ in decision-making style, negotiation approach, attitudes toward time, escalation methods, contract interpretation, communication directness. Managers should avoid assuming that one communication style is universal. Supplier collaboration should use relevant data. This may include forecasts, inventory levels, capacity, engineering changes, quality specifications, risk assessments, customer requirements, performance results. Sensitive information should be protected through appropriate access and cybersecurity controls. Real-world company example: Toyota. Toyota's purchasing approach emphasizes close communication and collaboration with suppliers. The relationship supports shared understanding across product development, production preparation, manufacturing, and supply. However, this cooperation still requires clear commercial agreements, quality expectations, timing, responsibilities, and performance requirements. CPIM key takeaway: effective supplier relationships require both trust and control. Contracts, data, communication, responsibilities, and escalation procedures should be clear. Let's summarize the 5 key lessons from Section A. First, select suppliers based on total value. Supplier selection should consider price, total cost, quality, capacity, delivery, lead time, technology, location, financial stability, sustainability, and risk. Second, choose the right sourcing strategy. Sole sourcing, single sourcing, multiple sourcing, onshoring, nearshoring, offshoring, reshoring, and friendshoring each create different cost, lead time, flexibility, and risk trade-offs. Third, match the supplier relationship to supplier importance. Routine suppliers may need simple transactional management, while strategic suppliers may require partnerships, collaboration, executive reviews, and long-term improvement plans. Fourth, measure supplier performance continuously. Supplier scorecards, certifications, audits, quality results, delivery performance, sustainability measures, and corrective actions help confirm whether suppliers are meeting expectations. Fifth, involve procurement early. Procurement should participate in new product introductions, engineering changes, supplier capacity planning, contracts, end-of-life planning, and supplier communication. Section A shows that procurement is not just buying at the lowest price. It is about selecting capable suppliers, managing relationships, reducing risk, and supporting long-term business performance. Section B, Purchasing and Maintenance. Section B, Overview. Procurement determines the broader strategy for acquiring external resources. Purchasing performs many of the transactions and activities required to obtain those resources. Maintenance ensures that equipment, facilities, and other assets remain capable of supporting the operating plan. Purchasing and maintenance both affect cost, availability, risk, quality, and customer service. In this section, we will study 5 key topics. Topic 1. Purchasing methods and purchasing documents. Organizations can use several methods to purchase materials and services. Purchase requisition. A purchase requisition is an internal request asking the purchasing department to obtain a material or service. It does not normally create a commitment with a supplier. Request for information. A request for information, or RFI, collects information about suppliers, technologies, capabilities, or market alternatives. Request for quotation. A request for quotation, or RFQ, asks suppliers to provide price and commercial information for a clearly defined requirement. Request for proposal. A request for proposal, or RFP, asks suppliers to propose a solution. It is useful when the requirement is complex and suppliers may recommend different approaches. Purchase order. A purchase order, or PO, authorizes the supplier to provide a specific product or service under stated conditions. It may include item, quantity, price, required date, delivery location, terms, specifications. Blanket order. A blanket order covers repeated purchases during a defined period. The total requirement may be agreed in advance, while individual releases are issued when materials are needed. This can reduce administrative work. Contract. A contract may cover a longer-term relationship, service, capacity agreement, or complex commercial arrangement. E-procurement. E-procurement uses electronic systems to support requests, approvals, supplier selection, orders, invoices, and payments. The selected method should match purchase value, frequency, risk, complexity, specification clarity, supplier market, and urgency. A company should not use an expensive and lengthy RFP process for a routine low-value purchase. It should also not use a simple purchase order for a high-risk, complex, multi-year service without suitable terms and evaluation. Real-world company example. Walmart. Walmart works with suppliers around the world and also supports supplier development. A large retailer must use structured purchasing processes because it manages many products, suppliers, locations, and customer requirements. Clear specifications, commercial terms, approvals, purchase commitments, and supplier information are necessary to control this complexity. CPIM Key Takeaway. The purchasing method and document should match the value, frequency, risk, and complexity of the requirement. Topic 2. Supplier scheduling, EDI, VMI, consignment, and pull releases. A purchase order does not always need to be issued separately for every delivery. Organizations can use several methods to release materials. Supplier scheduling. Supplier scheduling provides a supplier with planned requirements over a time horizon. The schedule may contain firm requirements, planned requirements, or forecasted requirements. The supplier should understand which periods are authorized and which periods may still change. Electronic data interchange. Electronic data interchange, or EDI, transfers structured business information directly between computer systems. EDI may communicate purchase orders, schedule releases, advance shipping notices, invoices, inventory information. Vendor-managed inventory. In vendor-managed inventory, or VMI, the supplier monitors agreed inventory information and is responsible for replenishment within defined rules. The agreement should define minimum and maximum inventory, service level, ownership, data accuracy, replenishment frequency, liability. Consignment inventory. In consignment, the supplier owns inventory until the buyer uses or sells it. This may reduce the buyer's inventory investment. However, the agreement must clearly define responsibility for damage, loss, obsolescence, and counting. Pool system. A pool system authorizes replenishment based on actual consumption. Kanban signals may communicate the need to replenish a defined quantity. Continuous replenishment. Continuous replenishment uses updated demand and inventory information to create frequent replenishment decisions. These systems require accurate data. If consumption is not recorded correctly, the supplier may replenish the wrong amount. Information sharing should also be secure and timely. Real-world company example. Toyota. Toyota's production and purchasing systems depend on close coordination with suppliers. Material requirements are connected with actual production needs and delivery timing. Frequent, controlled replenishment can reduce inventory and improve flow. However, it requires reliable suppliers, stable processes, accurate signals, disciplined transportation, and rapid communication. CPIM key takeaway. Advanced replenishment methods can reduce inventory and administration, but they require accurate data, clear ownership, reliable suppliers, and disciplined operating rules. Topic 3. Total cost of ownership and landed cost. Purchase price is only one part of cost. Total cost of ownership, commonly known as TCO, considers the complete cost created by acquiring and using a product or service. TCO may include purchase price, transportation, customs duties, taxes, insurance, inspection, handling, inventory carrying cost, storage, quality failures, maintenance, training, energy use, downtime, obsolescence, disposal. Supplier management. Landed cost focuses on the cost of bringing an item to the required location. It may include purchase price, freight, customs duties, taxes, insurance, brokerage, port fees, handling. Consider this example. Supplier A offers a component for $10 per unit. Additional cost per unit includes transportation, $1.50, import duty, 80 cents, inspection, 30 cents, additional inventory cost, 70 cents, expected quality failure cost, 50 cents. Total equals $10 plus $1.50 plus 80 cents plus 30 cents plus 70 cents plus 50 cents. The result is $13.80 per unit. Supplier B offers the component for $12. Additional cost includes transportation, 40 cents, inspection, 10 cents, inventory cost, 20 cents, expected quality failure cost, 10 cents. Total equals $12 plus 40 cents plus 10 cents plus 20 cents plus 10 cents. The result is $12.80 per unit. Supplier B has the higher purchase price but the lower total cost. The company should also consider risk. A low average cost may not be attractive when the probability and impact of disruption are high. Real-world company example. IKEA. IKEA sources products, materials, components, and services through an international supplier network. A sourcing decision must consider not only the quoted production price, but also transportation, packaging, compliance, quality, sustainability, inventory, lead time, and supplier capability. CPIM key takeaway. Purchasing decisions should be based on total cost and total value, not purchase price alone. Topic 4. Inbound logistics and external service providers. Purchasing is not complete when the supplier confirms the order. The material must reach the required location at the correct time and in the correct condition. Inbound logistics decisions may include transportation mode, shipment size, shipment frequency, routing, carrier selection, consolidation, cross-docking, direct shipment, point-of-use delivery, third-party logistics, fourth-party logistics. Common transportation options include truck, rail, air, ocean, pipeline, and intermodal transport. Full truckload, or FTL, normally uses most or all of a truck for one shipment. Less than truckload, or LTL, combines smaller shipments from different customers. Intermodal transportation uses more than one transportation mode. A third-party logistics provider, or 3PL, performs logistics activities such as transportation, warehousing, or fulfillment. A fourth-party logistics provider, or 4PL, may coordinate several logistics providers and manage a broader part of the network. The organization should evaluate trade-offs among cost, speed, reliability, capacity, damage risk, emissions, flexibility, visibility. A low-cost shipment may create production downtime when it arrives late. A very fast transportation method may protect customer service but create unacceptable cost. Advanced shipping notices can provide information before the material arrives. The receiving operation can prepare labor, space, equipment, and documentation. Real-world company example: Apple. Apple's global supply chain connects materials, components, assembly locations, distribution activities, and markets across many countries. Transportation and logistics decisions therefore influence lead time, inventory, risk, cost, and product launch performance. A low component price creates little value when the material cannot reach production at the required time. CPIM key takeaway. Inbound logistics should be planned as part of the purchasing decision. Transportation cost, timing, reliability, visibility, risk, and cost all affect the true supply result. Topic 5. Maintenance strategies and maintenance performance. Maintenance ensures that equipment and facilities remain capable of performing required work. Several maintenance strategies may be used. Reactive maintenance. Reactive maintenance occurs after equipment fails. It may be suitable for low-cost, non-critical assets whose failure creates little risk. For critical equipment, reactive maintenance can create unplanned downtime, production loss, safety risk, quality problems, emergency repair costs. Preventive maintenance. Preventive maintenance is performed according to a schedule. The schedule may be based on time, operating hours, cycles, distance. The objective is to reduce the probability of failure. However, maintenance may sometimes be performed before it is technically required. Predictive or condition-based maintenance. Predictive maintenance uses information about actual equipment condition. The organization may monitor temperature, vibration, pressure, oil condition, noise, energy use, wear. Data analysis can help predict when intervention is required. Total Productive Maintenance, or TPM, involves operators and maintenance employees in improving equipment effectiveness. Operators may perform basic inspection, cleaning, lubrication, and early problem detection. Maintenance performance may be measured using mean time between failures, mean time to repair, and equipment availability. Mean time between failures, or MTBF, can be calculated as total operating time divided by the number of failures. Suppose a machine operates for 600 hours and experiences 3 failures. MTBF equals 600 divided by 3. The result is 200 hours. Mean time to repair, or MTTR, can be calculated as total repair time divided by the number of repairs. Suppose total repair time is 12 hours for 3 repairs. MTTR equals 12 divided by 3. The result is 4 hours. Availability. A simplified inherent availability formula is availability equals MTBF divided by MTBF plus MTTR. Availability equals 200 divided by 200 plus 4. This equals approximately 98.04%. Maintenance plans should be included in capacity planning. Planned downtime is better than an unexpected breakdown during an important customer order. MRO inventory should also support critical equipment. However, holding every possible spare part is expensive. The organization should evaluate equipment criticality, failure rate, repair time, supplier lead time, and part availability. Real-world company example: Rolls-Royce. Rolls-Royce's Total Care uses engine health monitoring and predictive maintenance planning to support aircraft engine availability and reliability. Information from engine performance can help determine when maintenance should occur rather than relying only on failure or fixed intervals. CPIM Key Takeaway. Maintenance strategy should reflect asset criticality, failure consequences, repair time, cost, safety, and production requirements. Let's summarize the 5 key lessons from Section B. First, use the right purchasing method. RFIs, RFQs, RFPs, purchase orders, blanket orders, contracts, and e-procurement should match the value, risk, frequency, and complexity of the requirement. Second, manage supplier releases effectively. Supplier scheduling, EDI, vendor-managed inventory, consignment, pull systems, and continuous replenishment can reduce inventory and improve flow, but they require accurate data and clear responsibilities. Third, focus on total cost, not purchase price. Total cost of ownership and landed cost include transportation, customs, inspection, inventory, quality failures, storage, maintenance, downtime, and disposal. Fourth, plan inbound logistics as part of purchasing. Transportation mode, shipment frequency, carrier selection, consolidation, visibility, reliability, damage risk, cost, and emissions all affect supply performance. And finally, maintain equipment before it fails. Reactive, preventive, predictive, condition-based, and total productive maintenance strategies affect capacity, safety, quality, and customer delivery. Section B shows that purchasing and maintenance directly affect operational reliability. A cheap supplier or low maintenance cost can become expensive when it creates delays, breakdowns, shortages, or quality failures.
Quick reminder, if you're finding this helpful, don't forget to like, subscribe, and share with anyone who may benefit. Your support really makes a difference. Let's get back to it.
Section C. Risk Management. Section C Overview. External supply creates opportunities, but it also creates dependencies. Supplier failure, transportation interruption, political instability, cyber attacks, natural disasters, financial problems, quality failures, and capacity shortages can interrupt the supply plan. Risk management identifies uncertainty and prepares the organization to respond. The objective is not to eliminate every risk. The objective is to understand important risks and select appropriate responses. In this section, we will study 5 key topics. Topic 1. Identifying and categorizing external supply risks. External supply risks may come from many sources. Financial risk. A supplier may experience cash flow problems, bankruptcy, currency exposure, or rapidly increasing costs. Operational risk. A supplier may have limited capacity, unstable processes, poor planning, equipment problems, or labor shortages. Quality risk. A supplier may provide defective, inconsistent, or non-compliant materials. Delivery risk. Shipments may be late because of transportation, port, customs, weather, or scheduling problems. Political and regulatory risk. Tariffs, sanctions, trade restrictions, licensing rules, or government changes may affect supply. Environmental risk. Floods, fires, storms, droughts, earthquakes, or resource shortages may interrupt operations. Social and ethical risk. Unsafe working conditions, forced labor, discrimination, corruption, or community conflict may create legal and reputational consequences. Technology and cybersecurity risk. A cyber attack or system failure can interrupt orders, production, communication, and logistics. Concentration risk. Several suppliers may depend on the same sub-tier supplier, region, port, technology, or raw material. The buyer may believe it has multiple suppliers when all of them depend on the same hidden source. Risk mapping should therefore extend beyond direct suppliers when possible. Risk mapping may compare probability and impact. Suppose a risk has a probability score of 4 out of 5, an impact score of 5 out of 5. A simple risk exposure score is probability multiplied by impact. Risk score equals 4 multiplied by 5. The result is 20 out of 25. This score can help prioritize attention. However, numeric scores should support judgment, not replace it. A low probability event may still require preparation when its impact would be catastrophic. Real-world company example. Apple. Apple maps parts of its supply chain and uses risk assessments, standards, audits, and third-party verification to understand supplier and material risks. This is important because risks can exist below the direct supplier level, including processors, refiners, and material sources. CPIM key takeaway. Supply risk should be examined across financial, operational, quality, delivery, political, environmental, ethical, and technological categories. Topic 2. Supplier risk assessment and early warning indicators. Risk assessment should examine both the supplier and the supplied item. A supplier may be low risk for one item but high risk for another. Important supplier indicators may include declining delivery performance, increasing defects, frequent management changes, late financial reports, employee turnover, capacity problems, requests for early payment, loss of certifications, cybersecurity incidents, regulatory violations, longer lead times, poor communication. Important item-related indicators may include sole source dependency, long lead time, no approved substitute, high technical complexity, limited tooling, low inventory, short shelf life, high customer impact. The organization should create early warning indicators. These indicators can show that risk is increasing before a complete supplier failure occurs. For example, delivery performance falls from 98% to 92%. Defect rates increase for 3 consecutive months. Supplier lead time increases from 4 weeks to 7 weeks. A supplier repeatedly asks to delay payment obligations. One indicator may not prove that failure is coming. However, several negative trends should trigger investigation. The organization may also conduct supplier questionnaires, site visits, financial reviews, capacity audits, quality audits, cybersecurity assessments, continuity reviews. The depth of assessment should match the risk. A detailed audit may not be justified for a low-value office supply that is available from many sources. It may be essential for a single-source, safety-critical component. Real-world company example. IKEA. IKEA uses supplier requirements and audits to review policies, procedures, facilities, records, environmental practices, and working conditions. The purpose is not only to identify non-compliance after a serious event. The process also helps identify gaps and improvement requirements earlier. CPIM key takeaway. Supplier risk monitoring should use trends and early warning indicators rather than waiting for a complete supplier failure. Topic 3. Risk responses, redundancy, and strategic buffers. Organizations can respond to risk in several ways. Avoid. The organization may avoid a risk by changing the design, supplier, market, or process. Reduce. The organization may reduce the probability or impact through controls and improvement. Examples include supplier development, quality controls, preventive maintenance, better forecasting, shorter lead times. Transfer. The organization may transfer part of the financial effect through contracts, insurance, outsourcing, or warranties. Risk cannot always be transferred completely. The organization may still remain responsible to its customer. Accept. The organization may accept a risk when the cost of prevention is greater than the expected impact. Acceptance should be a conscious decision. Prepare. The organization may create contingency and recovery plans. Redundancy creates alternatives. Examples include multiple suppliers, alternative materials, backup tooling, alternative production locations, alternative transportation routes. Strategic buffers may include inventory, capacity, time. A company may hold additional inventory for a long lead critical component. It may maintain unused capacity for an important process. It may include extra time before a customer promise. Buffers are not free. They increase cost, investment, or lead time. The organization should place protection where it creates the greatest benefit. Multiple sourcing can reduce dependency, but it does not remove risk when all suppliers are in the same region or depend on the same raw material. The company should understand the real structure of the network. Real-world company example. Toyota. Toyota has developed supply chain information and continuity practices designed to improve visibility into important items and supplier dependencies. The rescue system supports supply chain information and risk analysis, helping the company understand which suppliers and components may be affected during a crisis. CPIM key takeaway. Risk responses should be selected according to probability, impact, cost, strategic importance, and recovery requirements. Topic 4. Scenario planning, analytics, and what-if analysis. Scenario planning evaluates possible future situations. The organization may ask, what if the supplier stops production for 4 weeks? What if the port closes? What if demand increases by 25%? What if material costs increases by 40%? What if a new regulation prevents the use of a material? What if transportation lead time doubles? For each scenario, the organization should evaluate customer impact, inventory, production, capacity, cost, revenue, cash, quality, recovery time, possible alternatives. Analytics can help compare options. The organization may evaluate alternative suppliers, alternative materials, order timing, inventory buffers, transportation routes, product substitutions, demand priority rules. Machine learning and intelligence may identify risk patterns in supplier performance, transportation data, weather, financial information, quality results, market conditions. However, a model may fail when the future is very different from the data used to create it. Human judgment and supplier communication remain necessary. Scenario planning should not attempt to create a plan for every imaginable event. The organization should prioritize situations that are plausible, high impact, or strategically important. Plans should be updated when products, suppliers, regulations, and networks change. Real-world company example. UPS. UPS uses analytics to adjust routes as traffic, pickups, deliveries, and operating conditions change. The same decision principle applies to external supply risk. Updated information should be compared with the current plan so that realistic alternatives can be evaluated before disruption becomes more serious. CPIM key takeaway. Analytics can improve risk decisions, but models should be supported by reliable data, operational knowledge, and clear assumptions. Topic 5. Supplier business continuity and disruption recovery. A supplier business continuity plan defines how critical supply will continue or recover after disruption. The plan should identify critical products, critical suppliers, sub-tier dependencies, emergency contacts, alternative sources, alternative materials, backup tooling, required inventory, transportation alternatives, recovery priorities, communication procedures, expected recovery times. The buyer should understand the supplier's recovery capabilities. A supplier may claim to have a backup facility. However, the backup location may use the same power network, port, information system, employees, or raw material. The alternative, therefore, may not be truly independent. The continuity plan should be tested. Possible tests include tabletop exercises, emergency communication drills, backup system tests, supplier response simulations, alternative routing tests. After a disruption begins, the organization may need to reprioritize purchase orders, use safety stock, expedite materials, approve substitutes, move tooling, use another supplier, adjust customer promises, reduce production, communicate with customers. Recovery decisions should follow established priorities. The organization should avoid using emergency decisions that create an even larger problem later. After recovery, the company should conduct a review. It should ask, what happened? Why did it happen? Which warning signs were missed? Which actions worked? Which assumptions were wrong? What should change? Real-world company example: Toyota. Toyota has strengthened supply chain continuity and supplier communication following major disruptions. Visibility into critical supplier dependencies allows the company to evaluate affected components, communicate with suppliers, prioritize actions, and support recovery. CPIM key takeaway: a supplier continuity plan should be created and tested before disruption occurs. Recovery requires visibility, communication, alternatives, priorities, and clear decision authority. Let's summarize the 5 key lessons from Section C. First, identify external supply risks clearly. Risks may be financial, operational, quality-related, delivery-related, political, regulatory, environmental, ethical, cybersecurity-related, or caused by supplier concentration. Second, monitor early warning indicators: declining delivery performance, increasing defects, longer lead times, financial weakness, poor communication, and loss of certifications may signal growing supplier risk. Third, choose the right risk response. Organizations may avoid, reduce, transfer, accept, or prepare for risk depending on probability, impact, cost, and strategic importance. Fourth, use redundancy and buffers wisely. Multiple suppliers, alternative materials, backup tooling, inventory buffers, capacity buffers, and time buffers should protect critical areas, not be added everywhere without a purpose. Fifth, prepare supplier continuity plans. Critical suppliers, sub-tier dependencies, emergency contacts, alternative sources, recovery priorities, and communication procedures should be identified before disruption occurs. Section C shows that supplier risk cannot be ignored until a crisis happens. Strong companies make risk visible early and prepare realistic recovery options before the plan fails. Section D. Sustainability Strategies. Section D. Overview. Sustainability considers how current decisions affect long-term environmental, social, and economic performance. External supply decisions may affect emissions, resource use, waste, water, labor conditions, communities, ethics, cost, resilience, and reputation. Sustainability should be integrated into strategy and procurement rather than treated only as a public relations activity. In this section, we will study 5 key topics. Topic 1. Sustainability and the triple bottom line. Traditional business decisions often focus mainly on financial results. Sustainability expands the evaluation. The triple bottom line considers people, planet, profit. People. People-related considerations may include employee safety, human rights, fair treatment, labor conditions, community impact, diversity, livelihoods. Planet. Environmental considerations may include greenhouse gas emissions, energy, water, waste, pollution, biodiversity, resource use, land use. Profit. Economic considerations may include revenue, cost, productivity, investment, risk, long-term competitiveness. The three areas are connected. Poor labor practices may create legal, quality, continuity, and reputational risks. Excessive energy use may increase both emissions and operating cost. Waste reduction may improve environmental performance and profitability. Sustainability should support long-term value. However, trade-offs may occur. A more sustainable material may initially cost more. Local sourcing may reduce transportation distance, but use a less efficient process. A recyclable package may require more energy to manufacture. The organization should evaluate the complete effect rather than relying on one visible characteristic. Environmental, social, and governance factors are commonly called ESG. ESG measures can be included in supplier selection and scorecards. However, measures should be clearly defined and supported by evidence. Real-world company example. Unilever. Unilever organizes its sustainability work around priorities including climate, nature, plastics, and livelihoods. These priorities affect products, materials, packaging, suppliers, operations, and value chain relationships. The example demonstrates that sustainability can influence business strategy and supply chain decisions, rather than remaining separate from daily operations. CPIM key takeaway. Sustainability should balance environmental, social, and economic performance over the long term. Topic 2. Responsible sourcing and supplier codes of conduct. Responsible sourcing establishes expectations for how products, materials, and services are obtained. Supplier requirements may address labor, human rights, health and safety, ethics, environment, working hours, wages, discrimination, forced labor, child labor, corruption, waste, emissions, resource use, land use. A supplier code of conduct communicates these expectations. However, publishing a code is not enough. The organization may also need supplier training, self-assessments, audits, corrective action plans, verification, performance reviews, escalation. A supplier that does not meet requirements may need to create an improvement plan. Serious or repeated violations may result in reduced business or termination. The organization should consider sub-tier suppliers. A direct supplier may meet requirements while obtaining material from an unacceptable source. Traceability can help identify the origin and chain of custody of materials. Supplier certifications may support responsible sourcing. However, certification should not be treated as complete proof. The buyer should understand what the certification covers, who issued it, how often it is reviewed, whether it applies to the actual facility or material. Responsible sourcing should be integrated into commercial decisions. A buyer should not demand the lowest possible price and shortest possible lead time, while ignoring whether those demands encourage unsafe or unethical practices. Real-world company example. IKEA. IKEA's I-Way code sets environmental, social, and working conditions requirements for suppliers and service providers. The framework establishes minimum expectations and supports improvement beyond the minimum level. This illustrates how responsible sourcing can be built into supplier requirements and ongoing relationship management. CPIM key takeaway. A supplier code of conduct creates value only when requirements are communicated, measured, verified, improved, and enforced. Topic 3. Carbon footprints, life cycle assessment, and supplier emissions. A carbon footprint measures greenhouse gas emissions associated with an organization, activity, product, or supply chain. Emissions may be grouped into Scope 1, direct emissions from sources controlled by the organization. Scope 2, indirect emissions from purchased energy. Scope 3, other indirect value chain emissions, including purchased materials, transportation, use, and end-of-life activities. For many companies, a large part of their carbon footprint exists outside their direct operations. Procurement must therefore work with suppliers. A product carbon footprint estimates emissions connected with a specific product or material. A basic carbon intensity measure can be calculated as total emissions divided by units produced. Suppose a process creates 10,000 kilograms of carbon dioxide equivalent and produces 5,000 units. Carbon intensity equals 10,000 divided by 5,000. The result is 2 kilograms of carbon dioxide equivalent per unit. The organization can compare this value over time or between alternatives. Life cycle assessment, commonly called LCA, examines environmental impacts across the product life cycle. The stages may include raw material extraction, processing, manufacturing, transportation, use, maintenance, end of life. A decision that appears environmentally positive at one stage may create greater impact elsewhere. For example, a lighter package may reduce transportation emissions but provide less product protection and increase damage. The organization should define the system boundary and assumptions used in the analysis. Without consistent boundaries, comparisons may be misleading. Real-world company example: Unilever. Unilever's supplier climate program works with priority suppliers and includes sharing product carbon footprint information for purchase materials. Because a large part of its emissions comes from raw materials, ingredients, and packaging, supplier collaboration is necessary for reducing its wider value chain impact. CPIM key takeaway: sustainability should consider environmental, social, and economic performance over the long term.
Topic 4. Sustainable materials, packaging, logistics, energy, and water. Sustainability strategies can influence many operational decisions. Materials. Organizations may consider recycled content, renewable materials, responsible sourcing, material toxicity, durability, repairability, recyclability. Packaging. Packaging should protect the product. However, unnecessary packaging creates cost, waste, storage, and transportation volume. Sustainable packaging may involve reducing material, using recycled content, improving recyclability, designing reusable packaging, eliminating unnecessary layers. Logistics. Logistics strategies may include shipment consolidation, improved vehicle utilization, shorter routes, intermodal transportation, lower emission transport, local sourcing, reduced empty travel. However, local sourcing is not automatically more sustainable. Production efficiency and total life cycle impact must also be considered. Energy. Organizations may reduce energy through efficient equipment, improved maintenance, process redesign, renewable energy, heat recovery, facility improvements. Water. Water management may involve reducing consumption, reusing water, preventing pollution, evaluating supplier water risk, improving agricultural practices. Sustainability should be integrated with planning. For example, waiting until the end of product design to consider packaging may limit the available alternatives. Early design decisions can reduce environmental impact and total cost. Real-world company example: Apple. Apple evaluates materials, manufacturing, product use, transportation, reuse, and recycling as parts of the product lifecycle. Its environmental and supply chain programs also establish requirements for supplier environmental practices. This illustrates the need to connect product design, materials, suppliers, logistics, and end-of-life processes. CPIM key takeaway: sustainable supply decisions should consider material selection, packaging, transportation, energy, water, quality, cost, and product protection together. Topic 5. Sustainability governance, metrics, and avoiding greenwashing. Sustainability goals should be translated into measurable actions. Possible measures include greenhouse gas emissions, energy per unit, water use per unit, waste generated,
waste diverted from disposal, recycled content, supplier audit completion, corrective action closure, renewable energy percentage, transportation emissions, product return recovery. Metrics should include a clear definition, a baseline, a target, a responsible owner, a measurement method, a review frequency, a deadline. Governance determines who makes decisions, reviews results, approves trade-offs, and responds to poor performance. Senior management should understand the relationship among sustainability, cost, risk, customer expectations, regulation, investment, supplier performance. Greenwashing occurs when an organization makes environmental claims that are unclear, exaggerated, unsupported, or misleading. For example, calling a product environmentally friendly without defining the comparison or providing evidence creates little useful information. A package may be called recyclable, even when suitable recycling systems are not widely available. The organization should use transparent assumptions and verifiable data. Sustainability reporting should not focus only on positive results. It should also explain limitations, risks, and areas requiring improvement. Supplier information should be validated where practical. Data quality is as important for sustainability planning as it is for demand, inventory, and capacity planning. Real-world company example: Unilever. Unilever's supplier climate work includes collecting product carbon footprint data and developing supplier capabilities. This creates a stronger basis for measurable improvement than relying only on general statements about sustainability. CPIM key takeaway: sustainability requires measurable targets, reliable data, ownership, governance, and transparent communication. Let's summarize the 5 key lessons from Section D. First, apply the triple bottom line. Sustainability should balance people, planet, and profit by considering labor conditions, environmental impact, cost, risk, and long-term competitiveness. Second, use responsible sourcing. Supplier codes of conduct, audits, certifications, corrective actions, training, traceability, and verification help ensure suppliers meet ethical, social, and environmental expectations. Third, measure carbon and life cycle impact. Carbon footprints and life cycle assessments help organizations understand emissions and environmental effects across materials, production, transportation, product use, and end of life. Fourth, make sustainable operational decisions. Materials, packaging, logistics, energy, water, waste, transportation, and product protection should be evaluated together rather than separately. Finally, avoid greenwashing. Sustainability claims must be supported by clear definitions, reliable data, measurable targets, ownership, governance, and transparent reporting. Section D shows that sustainability is not a marketing slogan. It must be built into sourcing, supplier management, product design, logistics, measurement, and governance.
Quick reminder: if you're finding this helpful, don't forget to like, subscribe, and share with anyone who may benefit. Your support really makes a difference. Let's get back to it.
Section E: Waste Hierarchy and Reverse Logistics. Section E Overview. Forward logistics moves products toward customers. Reverse logistics manages products, materials, packaging, and assets moving back through the supply chain. Returns may result from customer dissatisfaction, damage, defects, repairs, recalls, leases, rentals, product upgrades, recycling programs, or end-of-life requirements. The waste hierarchy helps the organization choose a preferred disposition. The goal is to preserve as much value as possible while meeting quality, safety, regulatory, environmental, and financial requirements. In this section, we will study 5 key topics. Topic 1. Understanding the waste hierarchy. The waste hierarchy ranks actions according to their preferred use of resources. The exact sequence may vary, but the general principle is to prevent waste before considering disposal. Prevent. The best option is to avoid creating waste. Examples include improving product quality, reducing forecasting errors, avoiding unnecessary packaging, preventing damage, designing durable products. Reduce. Reduce the amount of material, energy, packaging, scrap, or inventory used. Reuse. Use the product or material again without major transformation. Examples include reusable containers and return products sold again after inspection. Repair. Restore a product so that it can perform its intended function. Refurbish. Restore and update a product to an acceptable condition. Refurbishment may include cleaning, testing, replacement of parts, and cosmetic improvement. Remanufacture. Rebuild a used product through a controlled industrial process so that it meets defined performance requirements. Repurpose. Use a product or material for a different purpose. Recycle. Process materials so they can be used as inputs for new products. Recover. Recover energy or another useful output from waste. Dispose. Use landfill, incineration without useful recovery, or another final disposal method. Disposal is normally the least preferred option. The highest value option is not always technically, legally, or economically possible. A safety-critical component may not be reusable. A contaminated material may require controlled disposal. The organization should evaluate product condition, safety, quality, regulation, customer expectations, cost, environmental impact, available technology. Real-world company example: Patagonia. Patagonia's worn wear program supports repair, trade-in, and the purchase of used clothing and equipment. Keeping a product in use can preserve more value than immediately recycling or disposing of it. The example illustrates the preference for repair and reuse before lower value disposition. CPIM key takeaway: the waste hierarchy prioritizes prevention and continued use before recycling, recovery, and disposal. Topic 2. Designing the reverse logistics process. A reverse logistics process should define how returned products and materials move from the customer or field location to an appropriate destination. The process may include return authorization, customer communication, collection, transportation, receiving, identification, inspection, sorting, credit, repair, refurbishment, reuse, recycling, disposal. The organization should establish return acceptance guidelines. The guidelines may define eligible products, return period, required documentation, product condition, packaging, warranty status, reason for return, customer credit. Some returns may be routed directly to a repair center, a supplier, a recycling provider, a local store, a central returns facility. A reverse logistics network should consider customer convenience, transportation cost, product value, required speed, safety, data security, and regulation. The return process should record accurate information. Return reasons may include wrong item, damage, defect, customer preference, late delivery, installation problem, product recall. This information supports improvement. A large number of returns caused by incorrect picking requires a different response from returns caused by product design. The organization should also prevent return fraud. Controls may include serial numbers, receipts, customer records, condition checks, and authorization rules. Real-world company example: Apple. Apple Trade-in allows eligible devices to be returned for value, while other devices can be accepted for recycling. Returned devices are inspected and evaluated for reuse or recycling. This illustrates structured reverse logistics, collection, identification, condition assessment, data protection, value determination, and final disposition. CPIM key takeaway: reverse logistics should be designed as a controlled business process, not treated as an unplanned activity occurring after the sale. Topic 3. Product disposition, recovery value, and return metrics. Disposition determines what should happen to a returned product. Possible outcomes include return to inventory, return to supplier, repair, refurbish, remanufacture, harvest parts, repurpose, recycle, donate, dispose. The decision should consider product condition, remaining life,
safety, warranty, demand, repair cost, recovery value, transportation, environmental requirements, data security. A high-value product may justify detailed inspection and repair. A low-value damaged item may cost more to transport and process than its recoverable value. The organization should monitor reverse logistics performance. Possible metrics include return rate, processing time, recovery rate, repair success rate, percentage reused, percentage recycled, disposition cost, recovered value, customer credit time. Suppose a company receives 1,000 return units. It successfully returns 250 to inventory, repairs 300, refurbishes 150, and recycles 200. The remaining 100 units are disposed of. Units receiving a recovery outcome equal 250 plus 300 plus 150 plus 200. The result is 900 units. Recovery rate equals recovered units divided by total returned units multiplied by 100. Recovery rate equals 900 divided by 1,000 multiplied by 100. The result is 90%. However, the company should not improve the metric by selecting unsafe or uneconomic recovery options. Quality and regulatory requirements remain essential. Real-world company example: Cisco. Cisco's take-back and reuse program allows owners to return end-of-use equipment. The returned hardware can be directed to its next appropriate use through reuse, remanufacturing, refurbishment, or recycling. This illustrates structured product disposition and value recovery. CPIM key takeaway: product disposition should preserve the greatest practical value while protecting quality, safety, customer, financial, and environmental requirements.
Topic 4. Circular economy and design for recovery. A traditional linear economy follows a simple pattern: take resources, make products, use products, dispose of products. A circular economy attempts to keep products, components, and materials in use for longer. Circular strategies may include durable design, modular design, repairability, upgradability, reuse, product sharing, leasing, take-back programs, refurbishment, remanufacturing, material recycling. Circularity should begin during product design. A product is difficult to repair when components cannot be replaced, parts are permanently joined, repair information is unavailable, spare parts are unavailable, materials cannot be separated. The design team should consider disassembly, material identification, standard components, product durability, replacement parts, upgradable modules, safe recycling, ownership models. Ownership models can also influence reverse flows. A leased product is expected to return to the owner. This can provide better control over maintenance, reuse, and final disposition. However, circular business models also create planning challenges. The company must estimate return timing, product condition, repair capacity, spare parts, recovered inventory, customer demand. A returned product is not automatically usable inventory. It must be inspected and processed before it can support demand. Real-world company example: Cisco. Cisco's circular economy work includes product take-back, reuse, refurbishment, remanufacturing, recycling, circular design, and packaging improvement. The company aims to move equipment toward its next best use rather than treating end-of-use products only as waste. CPIM key takeaway: circular economy strategies should be designed into products, services, contracts, and supply networks before the product reaches the end of its original use. Topic 5. Recalls, deployed assets, alternate providers, and compliance. Reverse logistics also includes products and assets that are temporarily deployed outside the organization. Examples include rental equipment, leased products, returnable packaging, tools, samples, customer-owned materials, supplier-owned materials, subscription products. The organization should monitor location, ownership, condition, expected return date, maintenance status, value. Product recalls require controlled reverse logistics. A recall may result from safety problems, quality defects,
regulatory requirements, incorrect labeling, contamination. The company should be able to identify affected products. Traceability may require lot numbers, serial numbers, customer records, shipment records, supplier records. The recall process may include customer notification, product collection, quarantine, inspection, repair, replacement, credit, disposal, regulatory reporting. The organization may use alternate providers for reverse logistics. Examples include 3PL providers, repair centers, recycling companies, retail stores, specialized hazardous material providers. The organization remains responsible for selecting and monitoring appropriate providers. Products containing personal or confidential data require secure handling. Hazardous or regulated materials may require specialized transportation and disposal. Return policies should balance customer service, cost, fraud prevention, regulation, environmental objectives, quality. Real-world company example: Apple. Apple allows devices to be returned through online processes and physical stores for trade-in or recycling. The process must account for product identity, condition, customer data, transportation, reuse potential, and environmentally responsible recycling. This demonstrates why alternate collection locations and specialized processing partners can support reverse logistics. CPIM key takeaway: recalls, leased assets, customer returns, and end-of-life products require traceability, ownership control, regulatory compliance, secure handling, and qualified providers. Let's summarize the 5 key lessons from Section E. First, follow the waste hierarchy. The preferred approach is to prevent waste first, then reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, recover, and dispose only as the last option. Second, design reverse logistics as a controlled process. Returns need authorization, transportation, receiving, inspection, testing, sorting, credit, repair, recycling, disposal, and accurate data capture. Third, choose the best product disposition. Returned products may go back to inventory, return to suppliers, be repaired, refurbished, remanufactured, harvested for parts, recycled, donated, or disposed. Fourth, support circular economy principles. Durable design, modular design, repairability, upgradability, take-back programs, refurbishment, remanufacturing, and recycling help keep products and materials in use longer. Finally, manage recalls and deployed assets carefully. Recalls, leased assets, rentals, returnable packaging, and end-of-life products require traceability, ownership control, regulatory compliance, secure handling, and qualified providers. Section E shows that the supply chain does not end when the product reaches the customer. Returns, recalls, repairs, recycling, and end-of-life decisions must be planned to recover value and control risk. Overall, Module 5 summary. Module 5 introduced the planning and management of external supply and key support functions. External suppliers provide materials, components, services, equipment, technology, transportation, and capabilities that the organization needs to support customer demand. Supplier performance directly affects quality, costs, availability, inventory, lead time, sustainability, risk, and customer service. In Section A, we studied suppliers and procurement. We learned that supplier selection should consider price, total cost, quality, capacity, delivery, technology, location, financial stability, sustainability, and risk. Sourcing alternatives include sole sourcing, single sourcing, multiple sourcing, onshoring, nearshoring, offshoring, reshoring, and friendshoring. Each alternative creates different trade-offs. Supplier relationships may be transactional, cooperative, strategic, contractual, or partnership-based. The relationship should match the supplier's importance and risk. Supplier scorecards may include quality, delivery, cost, time, innovation, sustainability, and ESG measures.
Supplier certifications can provide useful evidence, but they do not replace performance monitoring. Procurement should also participate in new product introduction, engineering changes, and product end-of-life planning. Contracts should clearly define specifications, price, delivery, ownership, inventory liability, quality, information sharing, confidentiality, and dispute resolution. In Section B, we studied purchasing and maintenance. Purchasing methods may include RFIs, RFQs, RFPs, purchase orders, blanket orders, contracts, outsourcing, consignment, and electronic procurement. Materials may be released through supplier schedules, pull signals, electronic data interchange, vendor-managed inventory, and continuous replenishment. These methods require accurate data and clear responsibilities. Purchasing decisions should consider total cost of ownership and landed cost rather than purchase price alone. Inbound logistics decisions should evaluate transportation mode, shipment size, speed, reliability, visibility, damage risk, cost, and environmental impact. Maintenance strategies include reactive, preventative, predictive, condition-based, and total productive maintenance. We also calculated mean time between failures, mean time to repair, and equipment availability. Maintenance should be included in capacity planning because planned downtime is normally better than an unexpected breakdown. In Section C, we studied risk management. External supply risks may be financial, operational, quality-related, political, environmental, social, ethical, technological, logistical, or regulatory. Risk mapping may compare probability and impact. Early warning indicators can include declining delivery, increasing defects, longer lead times, management changes, capacity problems, and financial weakness. Risk responses include avoiding, reducing, transferring, accepting, and preparing for risks. Redundancy, multiple sourcing, inventory buffers, capacity buffers, alternative materials, and backup transportation can provide protection. Scenario planning, what-if analysis, machine learning, and artificial intelligence can help evaluate alternatives. However, data, assumptions, human judgment, and supplier communication remain essential. Supplier business continuity plans should identify critical products, dependencies, emergency contacts, alternatives, recovery priorities, and communication procedures. In Section D, we studied sustainability strategies. The triple bottom line considers people, planet, and profit. Sustainability should be integrated into supplier selection, product design, procurement, contracts, performance measurement, and governance. Responsible sourcing may use supplier codes of conduct, audits, certifications, corrective actions, training, traceability, and verification. Carbon footprint and life cycle assessments help organizations understand environmental impacts across materials, production, transportation, product use, and end-of-life processes. Sustainability strategies may also involve materials, packaging, logistics, energy, water, waste, labor conditions, and communities. Sustainability claims should be supported by measurable targets, reliable data, ownership, governance, and transparent communication. In Section E, we studied the waste hierarchy and reverse logistics. The waste hierarchy gives priority to preventing and reducing waste. After prevention and reduction, preferred alternatives may include reuse, repair, refurbishment, remanufacturing, repurposing, recycling, recovery, and finally, disposal. Disposition decisions should consider product condition, safety, quality, regulation, recovery value, demand, cost, and environmental impact. Circular economy strategies attempt to keep products, components, and materials in use for longer. Circularity should be considered during product design through durability, repairability, modularity, disassembly, reuse, take-back, and material recovery. The complete logic of Module 5 can be remembered through 5 questions. Which suppliers and sourcing strategies should we select? How should we purchase, receive, and maintain the resources we need? What external supply risks could interrupt the plan?
How can our sourcing decisions support long-term sustainability? And how should returned products and materials be recovered or disposed of? These questions connect suppliers, purchasing, maintenance, risk, sustainability, waste, and reverse logistics. Successful external supply management does not begin and end with negotiating a low purchase price. It requires total cost thinking, supplier capability, collaboration, risk visibility, maintenance support, responsible sourcing, and lifecycle management. In the next module, we will study inventory. Module 6 contains 4 sections: inventory planning, inventory costs and basic accounting, costing, and metrics, inventory management, and inventory control. We will examine inventory types, inventory classifications, item segmentation, replenishment methods, economic order quantity, safety stock, days of supply, inventory costs, inventory valuation, inventory accuracy, cycle counting, traceability, and inventory loss. Remember to review the topics using the CPIM 9.0 Full Learning Bundle. Test your understanding with the 6,200 MCQ Practice Bundle, and revise the important terms with the 1,800 Flashcards Bundle. The download link for all 3 bundles is available in the video description. Don't forget to like and subscribe to the Simple Understanding YouTube channel and activate notifications so you do not miss any lesson. Share this course with anyone preparing for the CPIM exam. See you next video.